Hello, this is Bobby at Copel TV Repair with a functionality proof video for power supply board PSD-0888. I have made other similar videos. I have made videos for how to test other sharp boards. So there will be nothing radically different. I have my plug here that helps me connect the standby voltage to the PS-on signal, which in turn activates the power factor correction circuit, which in turn activates the circuit for the transformers that provide a 13 volts here unregulated, as well as the 12 volts, which does require for the T-con. The 12 volts do require additional activation, for the sake of which I have this button here. So what this is one jumper from the standby to the power on. That is built in. As soon as I plug it in, the board will activate, and then there is a button that just sends 5 volts to the panel on pin, and you can find the history here in that table on your board. What we want to see is that we have 5 volts standby, which is one of the most common problems with that board. Just when it fails, there is no 5 volts at all. The second problem is the second goal is we want to see that the PFC raises to nearly 400 volts here over the main filter capacitors. Then we want to see the 13 volts, and when we activate and request the panel on, we want to see that. The one thing that this test does not do is it does not test the output for the LEDs. We'll have to pause that, I guess. Well, no, I do not. I'm sorry. So, let's get started. This is actually already turned on. I will get that here. Let me see if I can move those so that you see there is no gimmick. That board, that board will go to a customer who ordered it and they're overseas. And because of the high shipping costs, I'm focusing on something that's unique for that board. It is in addition to the label that showed today's date, 30th of November 2021, when the board came to us, it had a little damage here on this coil for the power factor correction, so it had to be covered with silicone. It is working fine now. So the first thing that we want to do is, let me take that off. The first thing that we want to do is we want to show that there is a standby voltage, and to do that we're taking ground here, and the most simple way to find standby is at the output of the standby rectifier, standby transformer. This is the rectifier for it, and the voltage there, as you can see, is 5 volts. It doesn't make a lot of good connection, that's why it's skipping some time. So we have 5 volts here. If we have it here, we're going to have it on some of the pins that are up there. And you will find out. Now the voltage over the PFC, over the main filter capacitors, will not be 400, it will be 160 something, let's see, 140, 166 is what you get there. Now when we activate the board, you will hear a click. You should hear a click coming from the relay. Okay, I heard it. I don't know if you did hear it. And several things will change. The first and foremost, which is the very first thing that should be tested on such boards, is the power factor correction working fine. Okay, we have 399. And that is fine. The next thing that we want to see is I'm sticking the ground here. The next thing that we want to see is the 13 volts unregulated. I don't remember on which of the pins, so I'm just going to try all of them. They will show up somewhere. Well, unless this doesn't make contact, of course. So let's force it a little. Go back again. This is the 5. Oops. Sometimes that happens. Okay, those are the 13. Shorted something by mistake. not fatal. This is lower voltage. So the 13 volts are here. And now the next thing that I'm going to do is the 12 volts for the T-CON board. It's another common failure for this board. It is on the last pin. That's why I'm sticking it here. I'm going to press that button with my pinky. And what you get is 12 volts, 12.17. Those are three of the most common problems with that board. No standby, no power factor, no 12 volts for the T-CON. Theoretically, that doesn't end it all, and there might be a problem here, but I have not seen so far a single board that had a problem of those. Actually, most of the other LED power boards with LED drivers, and actually most of the LED drivers, they rarely ever fail. For this particular model, or for Sharp boards in particular, I do not remember having seen a Sharp board with a built-in LED driver where the driver was bad. It's always the LEDs. I can think of a Samsung board that does have a problem with the LED driver. And that's one model out of the only model off the top of my head that I can think of a LG one that does have a diodes that burn sometimes, and that's about it. So anyhow, this is not complete. The complete test will require load on the LED side because it wouldn't produce the output voltage without load. But this is as good as it can get, and it's a reliable way of testing whether you do need a replacement board or not, whether you need to send yours for repair or not. Again, it's not 100%, but it's 99.99 statistically, so hopefully that will be good. Something more unique about that board, I think that's enough. Customers should be able to see. Thank you very much, and best of luck with your repairs. Also, if you're buying boards from us, please send yours back. This is something that will allow somebody else in your position who needs a working board to get one after we repair and test it, and it helps literally everyone. Even if it makes next to nothing money to you, we will work with you to make it so that you're not losing money. If somebody tried to work on the board, if it doesn't meet our condition for returning, please still return it. Thank you very much.